Good morning, I am Dr. J. Shankar, Professor in Department of ECE. Today we are going to see about discrete Fourier transform. So discrete Fourier transform can be calculated using two methods. One is called direct method, which is using formula of DFT, and another method is called fast Fourier transform. This is easy to calculate DFT using fast Fourier transform. There are two algorithms in fast Fourier transform. One is called decimation in time, another one is called decimation in frequency. Let us see these two algorithms now. Suppose if we are calculating using DAT algorithm, your input should be in bit reversal order, and we have to start with 2-point DFT first, then it is 4-point computation is calculated, and finally 8-point is calculated. The output will be in original order, so you need not do anything. Your output is same. If you apply DAF algorithm, your input will be in original order. Then you have to calculate starting from 8-point, then go for 4-point, and finally 2-point is calculated. Your output will be in bit reversal order, and then the basic butterfly diagram of DAT is, if two numbers like A, B are there, you have to multiply this B by a factor called twiddle factor, and then your upper values are calculated using A plus BW, and then the lower part is calculated using A minus BW. In case of DAF, again two numbers are there, and then these values are calculated using A plus B. The bottom points are calculated using A minus B into W and K. So now let us see a small problem. We are considering one sequence X of n, which is 1 2 2 1 and then 1 2 2 1. So this is 8-point sequence. We are going to calculate this using DAT. So in DAT you have to follow bit reversal order. So I am just calculating these values: 0 1 2 3 4 5 6 7. 0 to 7 is there. Now for my bit reversal order, I need to do bit reversal, which will be 0 4 2 6 1 5 3 7. This is the bit reversal order for 3 bits. Now we are going to write the input, which is 0 followed by 4 followed by 2, then 6, then you have 1 4 3 7. This is the bit reversal order of input. Now we are going to draw the basic butterfly diagram of these 8 points. In that case, you need to calculate using 2-point first. So in 2-point, we are going to use twiddle factor as 1, because all B's are multiplied by a twiddle factor. So this is my twiddle factor. So when you are adding this, since 1 is there, so you can directly add and then subtract. Likewise 4 0 0 2 0. Now we are going to calculate a 4-point sequence. In 4-point sequence, the upper two values are taken as A, and then the lower values are taken as B. So likewise we need to draw A to B 2 lines, and B is multiplied by W80 and W81. The same thing is applied in bottom values also. So this is 1, this is minus J. Again we are going for values like 6 0, adding A plus B and then A minus B. Then we have 0. Likewise we are applying in the next 4 values also. So we are giving 6 0 and then 2 0. Now what we are going to do is we are going to use 8-point DFT. In 8-point DFT, the top 4 values are considered as A, and then the bottom 4 values are considered as B. Again we are drawing lines between A to B, and then these all values are multiplied by twiddle factors. The twiddle factors for first case is 1, second case is W81, and then here it is minus J, and last value is W83. So W80, the value is 1 because we are calculating using twiddle factor. So it is given by e power minus j 2 pi by n. Now if you apply n equal to 8 and then substitute 1, you will get 0.707 minus j 0.707. Likewise, W82 value will be minus j. W83 value is minus 0.707 minus j 0.707. Now I am applying these two values and then adding 6 plus 6, that will give you 12. Likewise, this is 0. Here it is minus 2, and this value is multiplied by minus 2 into j, so it will become minus 2j, and here it is 0 again. This is 0, and now you are getting 0. Then this value will be minus 2 plus 2j, and my final value is 0. So this is since your input is given in bit reversal order, output is in order. So finally I need to write my x of k. My x of k will be equal to, I need to write as it is 12, 0, minus 2, minus 2j, 0, 0, 0, minus 2 plus 2j, and final value is 0. So 8 points I am getting. If suppose I am applying this same 1 to 2 1 using DAF algorithm, then I need to write the original order. It is in original order. Then I have to apply 8-point DFT first. If you are considering 8-point, again the twiddle factors are same. We need to apply the same concept here. So I have to draw lines between A and B. And then here twiddle factors are multiplied after subtraction. So after subtraction you are going to multiply. So this value will be 2, this will be 4, again 2, again this is 4, again it is 2. Here you need to subtract the values. When you subtract these values, this becomes 0. Now you need to apply 4-point. You have to take 2a and then 2b. So the bottom values will give you only 0. So the last 4 values are 0, and then if you come here, it is, so these values are 6 followed by, you have 2, then this is 4, and then this is 4 minus 2. Now you need to multiply this by minus j, so it will give you minus 2j. And finally you need to calculate 2-point for this. When you calculate 2-point for this, you can directly take 2 AB values, and then this is so this value will be 6 here. So this will be 12, and this will be 0, followed by this value will be minus 2 minus 2j, this value will be minus 2 plus 2j, and all other values are 0 here. So these values are bit reversal order. So it's 0426 1537. This answer is exactly like your whatever you have in DIT answer. Thank you for patient listening.